Welcome to the lesson, How Can You Make a Model? In this lesson, you'll investigate making and using models. What kinds of different models can we use? Click the images in the list. A model could be a miniature version of a large object. A model could be a two-dimensional drawing. A model could be a map showing geographical features. A model could be a game plan for a football game. A model could be a three-dimensional computer graphic. A model could be a diagram or instructions for making something. As you've seen, models are often used to help us to test how things will look or behave in the real world. This is useful because many things are expensive, dangerous, or difficult to try in real life. To model how things behave, we can use mathematical relationships, such as the distance, speed, time formula. Click the video play button to learn more. Modeling how a racing bike moves can help the manufacturers to improve the bike, or a rider to improve his performance. Scientists modeling a situation like this might use formulas for the bike's speed, the bike's mass, the rider's mass, the friction between the bike's tires and the ground, wind resistance, and so on. Different values can then be tried in these formulas to see how the bike and its rider would behave in the real world. In this activity, you'll be able to explore the use of a mathematical model. Here's what you'll use. A model of a cyclist. A control to vary their pedaling speed. A readout to show the time. A table to record results. You will use the model to investigate the following situation. The cyclist needs to get to the store before it closes. The store is 1 kilometer away and closes in 3 minutes. The cyclist could approach the journey in different ways. For example, he could pedal as fast as he can from the start, but then he risks running out of breath and not being able to finish the trip. Alternatively, the cyclist could pedal at a slower pace, but then he runs the risk of not making the store in time. Make a prediction. What strategy should the cyclist use to reach the store in time? Type your answer in the box, then click OK. Continue to see if your prediction is correct. You have a model of a cyclist who is trying to make it to a store, which is 1 kilometer away and closes in 3 minutes. You have a control to vary the cyclist's initial pedaling speed. Describe your plan for investigating what strategy the cyclist should use to reach the store in time. Type your answer in the box, then click OK. The cyclist shown here has got just 3 minutes to reach the store before it closes. The problem is, if he cycles too fast initially, he may run out of breath. If he goes too slowly, then he may not make it in time. In this task, you need to find the slowest and fastest initial speeds at which the cyclist could go, and still make it to the store in 3 minutes. Let's run some trials. Drag the slider to set. Click the Run button to start the cyclist. Too bad. The cyclist went too slowly and didn't make it on time. It looks like you need to try a faster initial speed. Click the Reset button to clear the Record the slowest and fastest initial speeds at which the cyclist can go and still reach the store in 3 minutes without going so fast that he tires out. Too bad. The cyclist went too fast initially and tired out. It looks like you need to try a slower initial speed. Good job! The cyclist reached the store on time. Good job! The cyclist reached the store on time. Think about your results. You modeled the cyclist's trip and varied his initial pedaling speed to investigate what strategy he should use. What strategy can the cyclist use to ensure he reaches the store in time? Type your answer in the box, then click OK. Continue to see if your prediction is correct. If the cyclist's initial speed is less than 5.5 meters per second, he will be too slow to make it to the store in time. However, if his initial speed is greater than 6.5 meters per second, he will run out of breath and not be able to finish the trip. So an initial speed of at least 5.5 meters per second, but not more than 6.5 meters per second, will allow him to reach the store in time. How does your conclusion compare with what scientists say about what the cyclist's strategy should be? Type your answer in the box, then click OK. We've seen how a math model can be used to investigate how a bike and its rider might behave in a real situation. As part of that model, we used an illustration of the bike and rider. A two-dimensional model could be used to see the side profile. A two-dimensional model could be used to see how accessories would fit. A two-dimensional model could be used to measure dimensions. A two-dimensional model could be used to plan color schemes. A two-dimensional model could be used to explain assembly instructions. A two-dimensional model could be used to see the bike from a different angle. The two-dimensional model is one way to model a bicycle. This model can help you to understand certain things about the bike, but not others. Another way to model a bicycle is to make a three-dimensional computer model. Each model has advantages and disadvantages. Can you think of some advantages and disadvantages of using a two-dimensional model compared to using a three-dimensional model for modeling a bicycle? Type your answers in the boxes, then click OK. Continue to see if your prediction is correct. You have learned a lot about using models. Before we finish, let's take a quick look at the main points you covered. There are many different ways to model objects and situations from the real world. A model can be a two-dimensional picture, a real or computer-generated three-dimensional structure. a set of formulas or equations, or a written description. Models are often an easier, cheaper, or safer way to test how things will look or behave in the real world. Different types of models have different advantages and disadvantages. Now that you've finished the lesson, click the Lab Report button to save or print it.